So today's lesson is going to be on Thales Theorem. So Thales Theorem states that the diameter of a circle always subtends a right angle to any point on the circle. So to understand this theorem, let's first draw ourselves a circle and mark its diameter. Now, what it means by an angle subtends is that if you pick any random point on the circumference of the circle, let's say this one or this one, as you can see, we picked 4 random points, and we're going to draw an angle using the 2 points of the 2 endpoints of diameter and connecting with the 4 points that we have. So here is one of our first angles, and then here's another one, and then another one, and another one. And as you can see, all these 4 angles were drawn from the diameter, the endpoints of the diameter, but they touch 4 different points along the circumference of the circle. And according to Thales, regardless of the fact that each of these are touching different points on the circle, all of them form a right angle. So, how do we prove this? Well, let's start off with our circle of and we'll mark the diameter. This will be our center point, and we'll call it O. And the 2 endpoints of the diameter were called A and B. And now we're going to pick a random point along the circle and call that C. And then after drawing the angle, we're going to try to prove that the angle ACB is a right angle. So, first thing I want to do is I'm going to connect O to C, as you can see with the green dotted line. And when I did this, you'll notice that the line OA is equal to OC because both of these lines represent the radius of the circle, because the radius is the line drawn from the center to any point on the circle. And when doing so, we've created this isosceles triangle since the line OA and OC are equal. So since that triangle OAC is isosceles, then that means that its base angles, which is a property of isosceles, are equal. So the base angles are angle CAO and angle OCA, and we can mark those as alpha. Now let's move on to the next step of the proof. And if you can, the same way we said that OA is equal to OC, line OB is also equal to OC because, again, OB is the radius. And because of this, the following triangle formed is a isosceles triangle because OB and OC are the same length, making the base angles, this time angle OBC and OCB, equal angles of the isosceles triangle. So we're going to call those beta, beta, the 2 equal angles. Now, we know that the sum of all the angles, all the interior angles of a triangle add up to 180 degrees. So if we add up all the angles in the triangle ABC, then we'll end up with alpha plus beta gives you 180 degrees. So if we simplify that, we will have 2 alpha plus 2 beta is equal to 180 degrees. And simplify that further by factoring out the 2, and that'll give you 2 times alpha plus beta equals 180 degrees. And if you divide both sides by 2, you'll end up with alpha plus beta is 9 degrees. And in our diagram, we see that angle ACB is represented by alpha plus beta. So that shows that angle ACB is equal to 90 degrees, and the angle subtended from point C is 9. Since the angle subtended from point C is 90 degrees, then we've proved Thales' theorem. That means that if we picked another random point on the circle, let's say this one, and we connected it with the endpoint A and the endpoint B, then this would also have created a right angle.